you actually have to have a paid account set up in order for that to take effect. And I just turned the record on, so I apologize. Once again, my name is Jeff Engel, Cloud Alliance Architect at Checkpoint, joined by Arun Punya at Oracle, Senior Solutions Architect, and Christian Castillo, Cloud Security Architect at Checkpoint. Just repeating myself, like I said, because I wasn't recording. Thank you, Jonathan, for pointing that out. So Arun, I'll let you go, and appreciate everyone's time today. And if you have questions in Espanol, Christian's here to help you, and he can overlay and help assist. And please use the Q&A as well for any questions. We have audio turned off, or we have we don't allow attendees to speak, but please use the Q&A, and we will be monitoring that to answer any questions that you may have. Thank you.
Sounds good. Thanks, Jeff. Hi, everyone. As Jeff mentioned, our today's workshop intention is to have a deep dive understanding of OCI as well as understanding of Checkpoint solution. So we're going to use the Checkpoint CloudGuard solution, and we're going to deploy that on OCI, and as well as we're going to do some traffic validation in the end. The intention would be like we're going to go over the outline first, then how the workshop outline looks like. Then we're going to cover a brief overview of the architecture. Then we will jump on the technical deep dive. So let's start. And if there are any open question and answer question, as Jeff already mentioned, ask them on Q&A. And if there is a relevant information around the link and all, you can always ask on the chat too. All right. So how the workshop outline will look like, we're going to provision our resources using Oracle Resource Manager. Oracle Resource Manager is nothing but it allows you to deploy resources using Terraform. Then I'm going to briefly cover how the manual steps look like. For example, if you are new to an OCI and you would like to deploy those resources manually, you can follow them along in the same workshop outline. Then we're going to cover how we can deploy the Checkpoint CloudGuard solution using Marketplace. So as Jeff mentioned earlier, if you are new to an OCI or existing customer, you have to have like a paid account. The reason is because OCI Marketplace listing, currently they are not exposed to free trial account. But using free trial account, you can deploy some VMs and all, network and resources and all. But the Marketplace listing is not exposed. So that's why for this workshop, the prerequisite is either you have your own tenancy, or if you don't have a tenancy, which is a paid account, you can follow along. This session will be recorded, and you can always walk it through afterwards. All right. So the next, what we're going to cover, like how you can initially configure the CloudGuard firewall as well as the manager, because we are going to use a Checkpoint Security Manager to manage our firewall configuration policies, routing, and all. Then in the end, we're going to inspect the traffic. The traffic inspection will have a couple of inspection, like one is like north to south, like inbound from outside, as well as north to south outbound to internet. Then we'll cover east to west traffic, which is like a spoke VM, spoke VCN, one spoke VCN to another spoke VCN. Okay. So how this workshop, which solution will you use from Checkpoint point of view? As I mentioned earlier, we're going to use Checkpoint CloudGuard Security Gateway. We're going to deploy the CloudGuard Security Gateway in high availability cluster. So it's like an active passive use case. So one will be an active firewall all the time. And when the failover happens, the passive one will become the active one. You need to have a paid account to access the OCI Marketplace listing. I'll briefly cover what are the different available listing of Checkpoint on OCI. At the same time, you can see how you can access those listings from OCI console. Currently, Checkpoint partner expose multiple listings, and they are in two flavors mostly. One is for bring your own license model, and another one is called paid listing. Bring your own license is exposed into US as well as non-US regions, and like all those international markets. And currently paid listings are available in US market. For example, if you have a tenancy which is built to US tenancy, then you can utilize those paid listing anywhere, like it doesn't matter where you are. But if you are have tenancy which is built to another country, then you can't access the paid listing at the moment. But there is a plan to expose that into internationally also. But there is just an FYI for this workshop. Currently, we're going to use bring your own license. The reason behind is because it comes with a like 30-day trial license. It's which fills our initial POC needs. Like we can do traffic inspection, we can do configuration, we can validate that initial use case which we want to cover in this workshop. But if you have question around like expanding the license and all, you can always reach out to Jeff and Christian, and you can extend your POC environment into production as it goes through. All right. So how the architecture will look like? As I mentioned earlier, we're going to deploy checkpoint in HA cluster mode, like high availability. So we're going to deploy 2 firewall. One is the CloudGuard 1, which is a primary firewall, and CloudGuard 2, which is acting as a secondary firewall, as a passive firewall. As you already know, checkpoint requires at minimum 2 VNIC as well as 2 subnets. And using 2 VNIC, you can achieve as a cluster. You don't need like multiple VNICs and all. But if you want to increase the compatible shape of checkpoint, so compatible shape are nothing but like when a checkpoint CloudGuard get exposed on OCI marketplace, there are certain shapes which are available on OCI. Based on those shape, and we say, okay, this particular listing is exposed to this particular compatible shape. And those shapes are mainly used for based on throughput or as well as like a VNIC use case. For example, if you have like 4 VNIC or 8 VNIC, and if you want to achieve higher throughput, so depending on that, you choose those compatible shape as per your use case. But in our case, using 2 VNIC, which is like VM standard 2.2 should be enough to deploy those resources. Even 2.1 should be enough. And we're gonna use 2 subnet, front-end subnet as well as the backend subnet. And as you see, we are following the hub and spoke model. So all those hub environment, like hub VCN. VCN is like virtual cloud network. So it's a logical entity of networking resources. So we're gonna deploy those hub VCN separately, and there will be 2 spoke VCN. One is for a web tier. Another one is the database tier. So web tier and database tier, they will be connected to the hub VCN via dynamic routing gateway. So DRG is a like logical construct on OCI resources. So it's like a routing. It's like a logical router which allows you to communicate between spoke VCN to the hub VCN. So currently DRG recent feature allows you to connect close to 300 VCNs. So this DRG is also responsible for any virtual circuit or any on-prem using IPsec tunneling and all. So those they terminate on the DRG. And based on the routing what you define there, you can send the traffic to the hub VCN to the firewall, and the firewall will inspect the traffic and all. Then it will send it back to the either on-prem, or if a traffic is coming towards spoke VCN, it will do that, all those use cases. But we're going to cover the basic use case of node to south, outbound to inbound, so inbound, outbound, between spoke VCN, and we'll see how the traffic goes through the firewall and how the routing works and all. At the same time, we are using internet gateway as well as service gateway. So internet gateway, the reason is because I want to connect outside to spoke VM. So I could go forward like using on-prem or virtual circuit. From there, I goes to the internet, or there's some internet gateway and all. But I'm using internet gateway just to see, so that way I can connect from outside as well as connect to internet. I'm also using a service gateway. Service gateway is another OCI service which allows you to expose to internal object storage or any OS and networks. The intention is, for example, if your spoke VM doesn't have internet connection, and if it wants to retrieve a certain object or bucket, and they can go through the service gateway directly. They don't have to go through internet. It saves like latency as well as like there is no explicit internet connectivity required. So that's the service gateway concept here. And each subnet will have its own routing table as well as the security list. Security list is nothing but which allows you to, by default, everything is blocked until unless you allow one security list or a network security group. So Oracle Cloud allows you to block everything like, until unless you allow it from your end. So our intention, since we want to inspect from firewall, we would be allowing the whole traffic and sending back to the firewall. So firewall, depending on the firewall policies and all, you're going to say, okay, you want to allow or don't allow, that's your use case, depending on how do you want to test it out. All right, so I think it's at this moment, I have pretty much covered all those hub VCN, spoke VCN, all those DRZ, internet gateway, service gateway, routing, and traffic flow will cover in once we validate the traffic. So what I'm going to do, I'm going to jump on then and how the workshop outline looks like. So if you are new to an LiveLab platform, you can search those LiveLab. It's a publicly available link. So let me share it here. Okay, so this link is like the reason I'm sharing it here because it's publicly available platform. Even if you don't have an OCI tenancy, even if you just want to understand how the environment looks like, how the OCI console, how the checkpoint solution looks like, you can use that LiveLab platform to understand it that. At the same time, it's best to have an OCI tenancy so that way you can have a hands-on experience, and that's the intention of this workshop. So what we do, you can see the outline here. This is the same outline which I was covering in the beginning. So like provisioning resources and all. So you can select any button here like free trial. As I mentioned earlier, free trial account doesn't allow you to expose to OCI marketplace listing at the moment. So you would need a paid account. Okay, click on run on your tenancy. So this will take you to an outline page. So let me open in a new tab. Okay. So this will take you to the introduction page. As I mentioned, like when it comes to security on any cloud, even for OCI also, it's always a shared responsibility model. So we like even any customer of cloud platform, they always rely on partner solution to make sure that they can use their checkpoint partner solution to secure their workloads running on OCI platform or any traffic coming from on-prem as well as OCI within OCI, you use that partner solution. So you can secure your workload. So that's the shared responsibility model calls. Like Oracle is responsible for security at certain point of view. And then when it comes to application security and all, then you use partner solution like checkpoint solution to secure your workload. So in this, okay, as I mentioned earlier, I'm going to use the bring your own license listing. But if you have a paid listing, which will give you an access to extended license, but there are certain costs associated to the paid listing. But in our case, we're going to use BYL because it gives you a 30-day trial license, and you can pretty much do all the POC which you want to test it out and get yourself familiar with that. Okay, so let me open this new tab because this is the same architecture which I already covered: 2 firewall, couple of VCN, DRZ, internet gateway, service gateway, and like on-prem or internet connection and all. All right, so the first step is like how, before we move on the next step, let's take a look on what is the OCI marketplace listing looks like. So go on to an OCI console, like if you don't have an account, you can create a free trial account and you should be able to access it afterwards. So once you log in here, you search for marketplace or all application. So it will take you to the same concept. So in this marketplace, you would see many publishers here, many partner solution here. But if you want to select a particular checkpoint one, you can select that from here, from the drop down. So as you see, as I mentioned earlier, Checkpoint has many solutions on OCI, and some of them are like either paid listing, some of them like bring your own license listing and all, and some of them are like a Terraform stack. So in our case, like this one is this one. Yep. Okay. So this is like a bring your own license listing. So which is like Checkpoint next edition firewall. So if you are new to an OCI, you can just search it. You have access to this listing on BYOL or paid, depending on which region you're selecting or coming from. But if you select that, then if you select a compartment like, workshop checkpoint one. So if you select the compartment, it will take you to launch instance page. But behind the scene, you will see there's an overview here. There's a related document. There's a support option here. So if you have a question, you can reach out to the Checkpoint support. There's a usage instruction also here. So it will tell you what is the initial configuration which you need to do once you connect. But anyhow, I'm going to cover it in the beginning. But if you are new to, if you're consuming from marketplace, you can always see the usage instruction here. All right. So on the marketplace, like it's just, not gonna launch it, but for understanding purpose. So if you click on launch instance, it will take you to the compute instance service of OCI. And once I cover the workshop, then I will show you like what is how you can launch it. But a small concept which I want to cover, like the compatible chef, which I've been talking about. So each listing is associated to certain compatible chef. So currently this particular listing, which I chose, as you see here, so and the E4 is grayed out, but E3 is compatible, as well like if you look at the Intel shape, like a 2.1 and all these shapes are compatible also. So if you, depending on what's your use case, how much throughput do you want to use and all, so you can choose that certain shape. And if you're curious to see the performance number, you can always search it online because it's globally available. So Checkpoint expose a certain performance number depending on their validation and testing. And they say, okay, which compatible shape has certain numbers and all. But in our case, you can choose minimum 2.1 because we need at least 2 VNI. One is for front end, another one is for back end. All right.
One thing to point out to make sure, if you go back to that screen real quick, Oracle and some of you, if you are aware or are familiar with OCI or are not, Oracle uses the term OCPU. And so in Checkpoint terms, licensing terms, OCPU is equivalent to 2 virtual cores. It'll actually show up as 2 cores within a Checkpoint system. So if you launch a 1 OCPU instance, you will see 2 cores available to you in a Checkpoint firewall, and therefore you need to license for 2 cores of Checkpoint firewall, of the CloudGuard network security, cores. Just keep that in mind. So it's you take your OCPU and then multiply that by 2 to get your required number of licenses needed.
Yeah, that's a good point. Yeah. So as I mentioned, 1 OCPU is equivalent to 2 virtual CPUs when it comes to licensing and all. All right. So the next part is like, since I covered this, the overview, I'll talk about there's a security management also. So let me just take back and go to application again. So this was the CloudGuard Security Gateway, but we also have a manager also here. So you can see this one. So we're going to use this one to manage the firewall. So which you can see there's a same way overview, user instruction and all. You can see those values here. All right. So what we're going to do, we're going to go into the next step now. But if you are curious to see, even though there's an official guide in each section of this workshop lab environment. So you can see OCI training, OCI console, networking and all. And there's an official document also, which points to the Checkpoint official guide, how you can deploy the Checkpoint solution on OCI. All right. So the next step is getting started, which is like creating a free trial account. I'm not going to go in detail, but in a nutshell, like you can go into free trial service, create an account. Once that account is ready, you should be able to access an OCI console, but that won't give you the marketplace listing. But that will give you certain like a credit and all, but and resources access. But the marketplace listing, you won't have an access to it. So that's the reason you need to convert that account to pay as you go, or have a paid tenancy already. All right. So the next step is when deploying the resources. As I mentioned earlier, I'm going to use the Oracle Resource Manager to deploy those resources because my intention is not to go through manual step one by one because that will consume a lot of time and might be boring also. But I'm going to cover that using Oracle Resource Manager. But we will cover some manual step and in detail, like lab 1 and lab 2. Those are like the manual steps here. So if you see here, if you wish to deploy the configuration manually, please skip lab 0 and continue from lab 1 onwards. So if you just skip this, then it's just the manual steps. All right, so each lab has its own prerequisite. So you can see repeating it here every time, paid account and access to these two listings. All right. So there are two ways you can deploy the resources. One is already like a zip file which is already provided here. And I didn't include the minimum resources zip file because I wanted to show how was the reason of minimum resources. So the reason is currently, if you see from this architecture, I'm deploying 2 VM here, 2 VM and 2 database VM also. But these 2 VM, they have a VM standard 2.4. But as Jeff mentioned earlier, usually what we do for the workshop, we send a prerequisite email. And in that email, we say, okay, you would need certain access to some VM shape for the minimum resource requirement. For example, in the Spoke VM, we're going to use the VM standard flagship, which is 1 OCPU, and VM standard 2.1 for Checkpoint CloudGuard and 2.2 for CloudGuard Security Management. So that's the comment about here, which you see here, click here, because the link is not there, but it will be available after the workshop once we finalize on the link and all. So, but I will share the link here. So I have the resources here. Let me find it out.
So just to say it in different words. So essentially what Arun is saying is we have two different Terraform packages that we can deploy. One that is kind of a full featured lab environment, which uses some larger size instance shapes. But then there's also this one that he's going to share now in the chat, uses basically the bare minimum required to run a good lab environment. But it works just fine. I'm using that in my lab personally, just for testing purposes, and it works perfectly. Looks good. Arun, can you zoom in on your browser?
Sure.
And so also to point out, as you'll see here, when we get into the labs, is Arun is actually going to be building kind of two side-by-side labs at the same time. And one will use the smaller resource requirement, and one will use the full resource Terraform package we have.
Correct. So this is the minimum resources one. So let me paste it here. So as you noted, I just pasted on my browser also, and I downloaded locally just to confirm it was downloaded successfully. So what we're gonna do, we're gonna search the stack here, and search, that will take you to Oracle Resource Manager. And we're gonna search our compartment. So for minimum resources, I created a compartment called Workshop Minimum. It doesn't have any resources at the moment. So what we're gonna do, I'm gonna click on zip file here, search for the file which I just downloaded locally. And as you see, I'm in the stack information. I'm just saying it's a bring your own license. You can update the name if you choose to. And this short description, make sure your compartment where you want to create the stack. This is for stack purpose. This is not for resources, but stack only. Then the Terraform part. So currently 1.1 and 0.14 should work for this stack. So I'm going to choose 1.0 because we tested that environment. And as you see, I've been saying that for minimum resources, we're going to deploy 2.1 for compute shape as well as the generic one. And we're going to deploy the E3 flagship for the Spoke VM, and security manager is going to use 2.2. So let me open a new tab here. So if I go into instances here, if I search the workshop minimum compartment, there is no instances here at the moment. So the intention would be we're going to deploy for minimum resources for this architecture. If you follow, we would need 2 firewall here, 1 manager here. We can go with the 1 web Spoke VM and 1 database VM. So in that way, we will need 2 VM here, 2, 4, and 5 total VM. So that's the link which I shared for the deploying 5 VMs. Search for your AD domain, paste your public key. It's already in my browser, so I'm just pasting that here. I'm going to choose the create new VCN and subnet. And that's the intention is as you know, Terraform allows you to use existing VCN or subnet also. because your Terraform is just nothing but provisioning. You can point them to existing resources. So if you want to use this strategy, you may have to modify the code in a bit, but you can do that.
Hey, Arun, sorry, can you zoom in on your browser again?
How about now?
I think I'll let. There's a couple of people asking. I think it looks. I mean, it's definitely better.
Let me see. 1 second.
I think that's fine.
How about now?
You're split screening between the PowerPoint and the browser. So yeah, I think it's fine.
Well, how about now? There's the like 250.
There you go. Yep, that looks good.
Okay, cool. All right, then. So I was covering the firewall part. So in the firewall, we are doing the hub in the hub one. As I mentioned earlier, in the hub, we are going to deploy this firewall 2 of the firewall here and MHA. So this is the firewall instance, firewall 1, firewall CIDR here. And I have put a name like management and all, but the intention is the management is the front end and trust is all the back end. But in the next one, when I'm going to deploy, you will see this, it has a correct naming and all. And then certain routing table name, web spoke name is like web spoke VC insider and web spoke private IP and all. And the private IP subnet, and same goes for database. And then in the end, we need to create some dynamic group and policy. So the reason of creating dynamic group and policy, because how the HA failover works on OCI from Checkpoint point of view. So Checkpoint has some custom plugin which talks to an OCI API. The reason of talking to the OCI API because we assign floating IP on each front-end interface as well as the back-end interface. And this floating IP is responsible for data traffic. So once the failover happens, this floating IP moves from primary firewall to the standby firewall. So that's the reason like we are creating dynamic group and policy because we are using instance principal mechanism method. So in that way, it talks to the OCI API, the plugin which is sitting on CloudGuard and operating system. We talk to an OCI API during the failover, and it retrieves the instance information and then move over that information to the standby firewall during the failover. So that's why we're creating a dynamic group and certain policy. You will see in a bit like what's the policy looks like and what's the dynamic group. In a nutshell, it's just an instance OSID which is attached to the dynamic group. Okay, so create stack here. So it's just once you complete the create stack, you're gonna do create here. I'm not gonna. I could have run the run apply from here, but I chose not to because I'm going to do the apply here. Okay, let me do the plan. Okay, so while this plan successfully complete in a behind the scene, so let me go to the workshop again because the intention was for me to use this link here because this is a publicly available link. So I'm going to click here and download it.
Can you zoom in on this page too? Sorry. Thank you.
Okay. So this one also, like I just downloaded the file locally. And so let me go to the stack here. I think I may have to zoom out a little because it's too much. Okay, 170. Okay, how does it look?
I think it's fine.
Okay. The reason I'm using bigger monitor because I have multiple screen. If I use the smaller laptop.
Yeah, no worries.
All right, then you choose your workshop checkpoint in the left-hand side compartment, and then you click the same way we're going to do the create stack, select the zip file, which is just download locally. So which one I did download now? Which one? 834. Okay. This one. It will have the name and all, which you can just modify. We choose to the stack name. The same way we're going to choose the compartment, which is a workshop checkpoint one. Then you would say there are certain resources 2.4 because it's a bigger shape, which I have resources in my environment, but you don't have to do that. you can always deploy the minimum resources. Same way, create new VCN subnet. Same way, like we have the firewall hub, VC insider, we're using front-end subnet cider, the DNS name and all. Same goes for backend subnet cider, and certain routing table name, which behind the scene you will see like what's the routing table points it to, because those are responsible for creating, attaching to the DRZ route, as well as sending traffic to the DRZ or receiving traffic from the spoke also. So web spoke VM is a VC insider, same way database spoke VM, VC insider and VC database subnet. Same way dynamic group. Let me put a different name because I didn't want to fail it over here. So demo 2 and demo 2 here. And click on next. So same way I'm going to create here. So I'm going to run the Terraform plan. So this Terraform plan is for the higher resources, and it's sitting on a different compartment. So it won't collide with the first one. Okay. All right. So the first one plan was succeeded successfully. So let me just do a Terraform apply. So Terraform apply should start deploying those all the VC and subnet which we talk about. Behind the scene, like this is the another one. So let me open a new tab. Search for instances. Choose the checkpoint minimum one. Okay. So you would see. So remember earlier I was talking about we would need at least minimum 5 VMs to test this workshop. So we have like 2 CloudGuard firewall. One is the manager and 2 spoke VM. One is in each spoke VM. And they are using some minimum shape which is 2.1, because 2.1 gives us 2 VNIC, which we need at least. And 2.2 is for manager for just for high 2 CPU. And then VM standard E3 flags. That's like those are like nothing but Oracle Linux VMs. So to test the traffic and the workshop part. And in a bit you would see like the VCN also. So minimum workshop. I'm not gonna go in detail because I'm gonna cover the workshop checkpoint compartment part. But in a nutshell, is deploy all those VCN we talk about. All right, so let me refresh it here, come back again. Okay, plan was succeeded here, same way, we're gonna do a Terraform apply. So our workshop outline and as well as detailed instruction will be focused on this compartment. I just showed it to the minimum resources just to prove, okay, it deploys the resources, it deploys the instances which we talk about, and what is the minimum resources and shape it looks like. But we're not going to cover that compartment. We're going to focus on the workshop checkpoint compartment here. So in a bit, you would see the instances are created here and all. All right. So as you know, it takes a little bit time. So let me go back to the workshop outline, which we are following. So we did that, downloaded it locally. We searched the Terraform stack. We uploaded the search in that particular compartment and created a stack here, uploaded the zip file, added the, you want to modify the name and just verify the description and compartment, and Terraform version, as you said, like 0.1 should also work. And then we updated selected the AD domain. So as you know, in OCI construct, like already domain is like a logical separation of making sure that you have resiliency, like resources high availability. So you can choose AD, or as well as you can choose the fault domain also if you have single AD within your region. Then the public key and then network compartments and all. We are choosing the create new VCN, as I mentioned here. Terraform, we did the Terraform plan as well as apply. Once the apply was successfully completed, you would see some certain instances are created here. So if I see my instances on workshop checkpoint compartment, so you would see there are 2 checkpoint firewall, 1 checkpoint manager here, and 2 spoke VM in each database VCN or webs VCN. and I'm using some public IP because I need to connect from outside. But if you have some other mean not to have public IP, you can always have a private IP and have access internally also. All right. So at this point, behind the scene, I'll show in a bit like both of the stacks should be completed and successfully completed. But I have mentioned here, like if you already did this part, you can skip lab 1 and lab 2. Because lab 1 and lab 2, those are manual steps. And lab 3 onwards, those are like in a firewall configuration and all. But I'm going to cover lab 1 and lab 2 because manual overview point of view. So in that way, people who are joining, they understand like if you're new to an OCA, how you can deploy the VCN, subnet, DRG instances and all. All right. So in the lab 1 environment, the first task is creating a hub VCN. So if you're new to an OCA, you can go to, okay, let me step back here. So the stack was completed on both of the compartment. Workshop checkpoint 1 successfully completed. And if I go into workshop minimum also, it was successfully completed. So that means like all the resources which I talk about, and based on this topology, they are successfully deployed on both of the compartment. All right. So we were going into lab 1 environment, so which is like creating VCN. So how you create a VCN. So you choose your compartment on the left-hand side, making sure you have the limit and quota, everything is met. Choose your region here, click on create, create VCN here, or you can follow this VCN wizard also. Well, in my case, I'm familiar with that. So you put the name of here like a checkpoint or however the name of VCN, select your compartment and enter your CIDR, which you want to assign. Choose like if you're using an IPv6 and all, but our focus is on IPv4 at the moment. Choose the DNS label and all, and click on create VCN. This will create a VCN for you. Then when the VCN is created, it comes with some default like routing table, default security list and all, but you would need to create a subnet here. So creating a subnet is just like create subnet here, enter the compartment, choose the subnet type, like a regional is like a recommended, AD specific, like if you want to deploy in one AD or AD1, AD2, AD3, depending on which AD you are using and which region, and enter your CIDR here. And then you choose the routing table. So route table could be default, and then you can modify at the later stage. And then you choose your private and public, depending on if you want to have a public IP assigned to your VM from that subnet, and have like outbound connectivity using internet gateway, or private something private. And if you want to use an outbound, you can use the net gateway or some net gateway concept, not internet, sorry. All right, then security list is just a security list which you choose. As I mentioned earlier, by default, everything is blocked until you allow everything from my end. So for workshop purpose, I have created a new security list, which I will show in a bit. This is allow all, which allows ingress and egress also, both of them. Then tagging is like, as you already know, the tagging is nothing but which allows you to track your resources from cost point of view, as well as a provisioning point of view also. All right. So in the first workshop, task was creating hub VCN, which we covered. I showed you how to create a hub VCN. Same way in the hub VCN, within the hub VCN, we also created two subnets. So firewall VCN, the front end subnet and back end subnet, which I showed you how you can create a subnet. So each subnet has its own CIDR and access type and all. So in our VCN, you would see there are two subnets here. One is the public one is private one. Then we covered, okay, we didn't cover the internet gateway, but internet gateway is something here. You can go click on internet gateway here, click on internet gateway, choose a compartment and put the tag if you choose to, and click on here. So it will create an internet gateway. But you would need to have like a route pointing to this internet gateway to go out. So which we'll cover in a bit. Internet gateway, then service gateway, which I talked about earlier. Service gateway allows you to connect to object storage or Oracle service network internally. So the same way which you did for internet gateway. Let me close this one. Okay. So this is the service gateway here. Click on create service gateway, put the name, choose the services, object storage or all ID services internally, like internal network, one service network. You can follow the official document here to learn more about what are the services are exposed. All right. So in a bit like a service gateway, which we covered, then the next step was creating a web VCN and database VCN. So the same way, I'm going to VCN here, choose the web VCN here. So as you see, we already have the web VCN, which has a certain CIDR here. Within the web VCN, we have certain subnet. So if you notice here, I didn't use the /24. So the reason I didn't use, because I wanted to pinpoint here, the intention is you always should use /24 subnet to the whole subnet if you want to inspect the whole subnet. If your use case is something different, if you don't want to inspect the particular subnet, then you can create another subnet here, and then but those subnet won't know. Like if you have like another let me create another subnet here, which you'll see 10.0. Okay. Okay, so now you see there's another subnet called test. So if a test VM is trying to talk to application private, it won't go outside of this VCN. Since it won't go outside of this particular VCN, it will never reach to this DRG. So any traffic between those test subnet and the application private subnet, they can communicate each other, but they will never be inspected by a firewall. So that's why I didn't create that another subnet, I didn't consume the /24. But in production environment, the intention is you should always consume the whole subnet CIDR. So in that way, you inspect the whole subnet. Because in my case, like if you see here, this test is a different /25. This is another /25. If they talk to each other, they will never go outside this VCN. So they will never ever go to the firewall. But if you had like whole /24 here, then the whole subnet will be inspected and that will go outside. All right, so this is the one which we created, the web VCN. It has a web VCN subnet, the same way which you can create VCN, same way you can create a subnet within that particular VCN here. Okay, the next task is the creating database VCN. So the same way we can create a database VCN, choosing a compartment and all. Since we already talked about it a couple of times, I'm just going through overview. Creating a VCN CIDR here. It comes with a default value as I talk about. Then you create a database private subnet. Then you choose those like a CIDR and private and all those security lists which we talk about. Okay. The next step is the creating DRG, dynamic routing gateway. So you can search the dynamic routing gateway here. Choose your compartment on the left hand side. Select the, if you are new to Nausea, you can click on here. It will create a DRG for you, but I'm not going to create one because I already created using Oracle Resource Manager. This DRG in a nutshell, it should currently, since I'm using Oracle Resource Manager like Terraform, so I already created all those attachment and all, but if you would see those attachment here. So if you see each VCN, it has its own attachment here. So as I mentioned in the beginning, the intention is like our DRG will have attachment to each VCN. So this attachment is responsible to sending the traffic from particular VCN towards the DRG. So that's why we have created this attachment here. And depending on how you want to route the traffic and all, you can assign the route table here. So let me quickly overview here. So there, how you can create a route table here. You can create a route table by clicking on here, click the route table, enter the CIDR here, choose your next hop. How would you want to route, and choose your firewall VCN attachment, or like how you want to, which attachment you want to send the route to. Similar fashion, you can create another route table entry and all. But we already created that using the Terraform. So the first route table is to firewall. So intention of this route table is any traffic coming from any VCN, spoke VCN, you want to send it to the firewall VCN. So in that way, firewall VCN attachment knows about it and it knows how to send the traffic to the firewall. So we are sending the whole subnet slider to the firewall VCN attachment. So if I click on here, it will take you to the firewall VCN attachment type, and attached to the VCN is the firewall VCN. Then you will see there's a VCN ingress route table. So this VCN route table is responsible for sending traffic to the firewall. So if I go click on VCN ingress, I just open a new tab here. So you will see there you will see there are 3 route table. You don't need like bottom 2 here because I already have 00. But then, for example, if you don't have 00, if you want to assign only a certain slider, so that's the only reason I created them, just to show visibility point of view. So in this one, these are like web VCN, this is a database VCN. And how would you send it to that firewall? So what you do, like you send it to the private IP. Private IP is nothing but the floating IP, which I've been talking about. And this floating IP is the backend interface. So if I click on here, ideally it should take me to the primary firewall instance and the backend interface IP. So it should take me to this primary firewall. So what we saw here, traffic came from WebSpoke VM via the DRG attachment. DRG attachment has firewall VCN attachment also. Then we saw a VCN ingress route table. That VCN ingress route table is part of this VCN, hub VCN, and it is pointing to the backend interface. So if I click on this one, I already clicked here. So you will see there's a backend here, which has a multiple IP, like this is the floating IP, which is responsible for data traffic and all. And that's also responsible when the HA failover happens. You will see this 2.4 moves from primary firewall to the secondary firewall. So if I click on attach VNIC here, it will take me to CloudGuard 1. And CloudGuard 2 should not have those floating IP at the moment, because CloudGuard 2 doesn't know about the secondary IP until unless the failover happens, which you will see in a bit when we configure and all. In the same fashion, like in the front end one, you can have the additional IP here, which we're going to use, the floating IP and all. And there's another concept here, like in the same VNIC, you can assign multiple secondary IP addresses here. For example, if your use case requires multiple public IP access from outside, or if you want to point it to another IP and all, you can assign those secondary private IP addresses here. You can choose reserve public IP, or you can create new one depending on your limit and quota on your tenancy. All right, so this is the one which I talk about. Let me take you to CloudGuard 2, just so that we know in the beginning, there is no floating IP as well as the floating IP on the backend and the front end, both interfaces. So there is no floating IP here on the backend, and the CloudGuard 2, same way there is no floating IP on the CloudGuard 2 also on the front end. Those will be there when we validate the traffic part. We're gonna do an HA failover. All right, so we covered the 2 firewall route table and the from firewall, how the return traffic will come. So if you see the from firewall route table, it has an import route distribution. Like dynamically, we are importing the routes from each spoke VCNs. So if you click on transit spoke, so you will see there are 2 attachment of web VCN and database VCN. And based on that, like it knows how to return traffic, where it send it to, like which spoke VCN. For example, traffic comes to hits the DRG return response, hits the DRG, then the DRG should know how to send it to each spoke VCN. So that's the reason of creating those route distribution and all. And you can create one by click on the route distribution here, and you can just add those value based on another routing priorities and all. And how would you attach the route table? So you click on each attachment, because usually attachment when you create the first time, they have their own default route table, but you can click on advanced option here and you can choose the route table. For example, in our database VCN and web VCN, we're going to use the from firewall route table. And if it was the firewall VCN, then we can click the VCN route table and all. But since this is not the firewall VCN, let me just take it to firewall VCN here. Add it here, and that's where you're creating the VCN ingress route table, attaching it here. So you see, I'm seeing the additional route table within the same VCN, but in our case, and the focus is VCN ingress one. And how there's one more thing which I want to cover, like the return response. So I'm going to focus on the trust subnet at the moment, but sorry, backend subnet. So backend subnet has its own route table. So in this backend route table, you see here, so the return response is like web VCN, and this is the database VCN, and this is for a service gateway, which we're talking about, like how you can send it to the service gateway. So if you see here, I'm sending it to the DRG. So if you are new to an OCI, you can click on add route table, choose your target type. So if you choose the dynamic routing gateway, because of the attachment, it knows which DRG and which compartment it's already part of that, it knows about it. So you can send that, you can choose your CIDR here, and you can send it to the DRG with the return response from this backend subnet. And that's backend subnet route table, you can attach to the subnet level. So if you click on subnet here, click on edit here, you can choose the route table. And as I mentioned earlier, like I'm creating a security list. So in this security list, I'm creating an allow all. So click currently ingress and ingress rule. They're allowing all IP address and protocol. And if you don't want to restrict, you can restrict some certain CIDR. So you choose CIDR here, choose your protocol like ICMP or SSH or TCP UDP, depending on which one you want to block or some service. Same way you can add more rule within the same construct, or you can add it afterwards. Same way you can add the egress rule also. But for our use case, I want to allow all, because I'm going to send the traffic to the firewall, and firewall will be responsible for blocking or allowing and all. All right. So we covered, I think, a lot of topic here when we're covering the DRG. So we covered the DRG part, how we create the DRG. Then we covered how you can attach the attachment. So, okay, I didn't do that, but let me just show quickly here. Click on create VCN attachment. I think I did. So you can choose the VCN attachment from the drop down. Then
and the beauty of this workshop is that it's a permanent learning, a permanent training module that you can go back to, and the details are all in the instructions. I know we're going through a lot of information here, but all of it will be on this video, if you play it back, but also in the instructions with screenshots and walking you through all the manual steps. This also highlights the benefits of using Terraform to automate a lot of the point and click and the manual configuration. So this is good.
Exactly. Yeah. So as I mentioned, our intention is to have an overview of each solution, like OCI as well as checkpoint. I'm covering the OCI at the moment, because once we focus on the firewall, then that will see some fun about it, like the traffic part and all. All right, so this one, the firewall VCN, we talk about route table, and we already, same way you can create the web VCN, attach the route table. Then we cover the database VCN also. We covered the to firewall route table. Then we covered the from firewall route table also. Then we covered how you can attach the route table, which I showed you on the firewall VCN as well as the spoke VCN. Okay, and then import route distribution, we covered that also. We can attach the import route distribution. This is like a screenshot, just clicking on the route table, click on edit and select the enable this check mark and select the route distribution here. Okay, same, the next step is the route table. So, okay, let me step back. We were focusing on the firewall VCN. So in firewall VCN, we have two subnets. So the backend one is the route table here, which is responsible for sending to the DRG. You would see some entry on the front end, but that's not needed. That's just to show end user like how you can add the route table. This is not needed because but if you are sending some on-prem traffic, then you might need something like that from the front end side. But if these are not needed at the moment, but this is just for a test purpose, just to show it to you. All right, and you can create a route table here by clicking on here. Same way, that's why we created a couple of route table, backend route table, service gateway, VCN ingress and all. All right, so this is the dynamic routing gateway, which we talk about, update route table, which we already covered, the ingress rule. So this is ingress and egress, which we covered, allow all. Adding route table, which we covered, like how you can attach the route table pointing to the DRZ. The same way you can done on database VCN, I'll show in a bit, like it's already there. And same way you can do it on the security list, which we talk about internet gateway also. So if I go into this front-end route table, so you will see there's a route entry, which is pointed to internet gateway here. So you can select this route table, choose internet gateway, and that will choose the internet gateway from drop down and enter the CIDR which you want to connect to outside and all. Then this one is the internet gateway, which you covered, backend route table, which you already covered. The backend one, VCN ingress, we covered in detail also, adding the route entry in the VCN ingress also. Firewall VCN, this is the same security list which we've been talking about, ingress rule and egress rules. And this is we covered in the one, like when we were trying to attach the VCN ingress, I showed you to how you can select that particular attachment and update the entry. Okay. The next part is launching the instances and the web VCN and database VCN. So if you're going to search for instances here, or you can search for compute instances also directly from there. So how do you launch an instance? So once you launch an instance, choose the create instance here from GUI. Choose the AD specific, or you want to assign a certain fault domain, you can do that, which I've been saying there. Then you choose instance shape image, because in Spoke VCN we are focused on, you can choose Oracle Linux or another platform if you choose to, and certain shape, because you can keep it default. If you want to change the value, you can choose it. Then networking part is like you can choose a compartment if you want to point to a different compartment. But since our case, all the resources are sitting in the same compartment, then you choose your VCN here, or you can enter like either create a new VCN or enter a subnet OSIT directly, and choose your existing subnet from drop down, and assign a public IP if it is a public subnet, or if it is a private subnet, you will see the public IP you can assign. And upload your SSH key. Either you can use this private public key, or you can upload one from locally. And once you click on create, you would be able to create those VCN, create those instances into each database VCN, as well as like if you choose the web VCN, the web VCN also. So I'm not going to create them, but the intention of this workshop task 6 and 7, they focus on like creating instances on database VCN and the web VCN. All right. So at this point, I think it's a good time to take a 15-minute break before we move to the next step where we can create the checkpoint CloudGuard part.
Sounds good, Arun. So we will start back up at, let's do 20 minutes after the hour. And I'll put that in chat as well. That'll give you guys a chance to answer emails, go grab some coffee or beverage of choice, maybe a snack. And then we will start back up and show some more of the checkpoint side of the things. Appreciate your time and patience, and feel free to make sure to use the Q&A to ask any questions. Happy to answer anything that you have questions about. All right, we are at 20 minutes after. We can resume, Arun.
All right, thanks, Jeff. Thanks, everyone. So as you noticed in the last lab environment, we covered the deployment of resources. We covered the manual overview of different component of like a VCN, subnet, security list, and creating instances into a Spoke VCN. So the next fun part is we're going to we're going to have an overview how you can deploy the resources of CloudGuard from OCI Marketplace. And then we're going to move towards the initial configuration and the traffic validation part. Let me pause my background. All right. So in this lab 2 environment, so if you see it here, there are certain prerequisites, and each lab has its own objective, which can tell you what we're going to do in this lab environment. So, okay. So the first step is you need to deploy Checkpoint CloudGuard Security Management Platform. So as you noticed earlier, like when I was showing in the beginning, you can search that application here. So in the similar fashion, you can search the CloudGuard Security Management. So let me search it from here. Okay, this one. So we click on launch instance here. So choose the version which you want to deploy. I believe we are using R81 release. And if you choose that version, then you click on launch instance. It will take it the same way. We already covered the compatible shape, which you can select it here, update the value. In the similar fashion, you can select your VCN, subnets, assign a public IP, and like a SSH key and all. So it's pretty much, the concept is pretty much same, how you do it any instance. The only concept changes is this image is coming from Marketplace. So either you can go to return to Marketplace, or if you are directly creating an instance here, like for example, if I want to create instance here, you can choose the image here. So you can choose the partner images. From partner images, you can search the partner image. For example, next one. Okay, this one. So you can choose that CloudGuard one. So these are the paid one, which I don't need. Focus on bring your own license for part management platform. Or if I was using just bring your own license platform, I could have used that just a firewall only. There you go. This one. And once you do that, so if you scroll down here, you would be able to select the same version which you were seeing on Marketplace part. You would see those versions. And in a nutshell, like once you do that, then you need to accept the agreement. Agreement is nothing but like any partner, any terms and conditions, you can review them, but it's just a pretty generic one. So once you select that image, then you would see what is the compatible shape. So this shape so it will give you a warning. Okay, E4 is not available in current domain, so I need to change.
But will be soon.
I will be soon. Yeah, true.
Yep.
And I think X9 also, you're also working towards that, right?
Correct. The E3. Intel E3 Flex, the optimized Flex will also be supported soon. Correct.
So E3 Flex, and just an FYI, it gives you like a higher throughput. When I say like using one OCP, you can achieve like close to 4 GB throughput. So depending on like if you I can't modify it here, but you can see, you can read more about like the shape size and all on OCI document. All right. So we were covering that. Okay. So I covered that checkpoint manager. Same way you can deploy the CloudGuard 1 and CloudGuard 2. So we are using R81 release and revision 1, revision 0. I showed you like an example how you can deploy the partner images. Same way, like you can choose the VCN, assign a public IP and all, and upload your SSH key. Okay. It also allows you to push the cloud init configuration, which I forgot to show you here. So
yeah, but at the moment, the images that we provide do not support cloud init, but that is on the roadmap for sure.
Correct. So then, as Jeff mentioned, once that happens, like you can push the cloud init configuration. So Jeff, correct me if I'm wrong, that you still allow the SIG key and all, right?
Yeah, so there are some things in the basic deployment mechanism that allows us to set SIG and do some things. So yes, absolutely.
Okay, so that's why this workshop covers the initial basic configuration, which is like a secure secure communication key. So that's one, and then some basic construct. So you can put that value into this cloud init configuration part, and based on the how do you want to, like what's your password looks like and all. Same way we did the CloudGuard 2, it will follow the same concept. You choose your version, choose your platform image, or directly launch it from marketplace, sorry, partner image. And same way you do the images, assign IP and all. So if you notice here, like when I was creating vSIN, there wasn't an option to add additional interface. So currently on OCI, when you launch an instance the first time, you can have only one instance, sorry, one interface on that instance. So that's why the reason I was using Terraform, because Terraform dynamically I can add additional interface as soon as the resource becomes like a running mode, right? So as soon as the instance is running, I can add those instance interfaces. So what happens, like let me show quickly how you can add interfaces. So click CloudGuard 1, click on attach VNIC, click on create VNIC here. From there, you can add that VNIC here, and you can choose your VCN where you want to attach the VNIC, subnet 1, and skip source to destination, because in this concept, like we're gonna send the traffic to the firewall. So that's the firewall use case. You need to follow the traffic to the firewall. That's why we need to select that one. And you want to assign private IP, you can do that depending on which subnet it is, like a front end or back end. So you can also assign a public IP. And click on save changes, and that will create a new VNIC over here. So that's why you will see another VNIC, because I was using Oracle Resource Manager like Terraform, and in that when I added an VNIC dynamically. All right, so this is the add interfaces. So in CloudGuard, on CloudGuard 1 and CloudGuard 2, we need to have like each instance should have two interfaces. One is for front end, another one is for back end. So that's what you will see here. The back end one, I'm doing the CloudGuard 1, and then making sure the skip source to distance check is enabled. CloudGuard 2, making sure that selecting it, making sure it's enabled. Then IP address, assigning secondary IP address, which we have covered in the long time, like in the beginning. But let me quickly have an overview. It's just once the VM has a VNIC attached to it, it will have a certain IP to that. But if you want to assign an additional IP, you can click on assign secondary private IP. And that's the same way I'm doing it from Terraform. Like I'm just assigning a secondary IP, and that's the floating IP. And you would see only CloudGuard 1 needs to have those floating IP. So CloudGuard 1 has a, this is for front-end one, which needs a public IP also for going outbound connectivity, and the back-end one, which doesn't need any public IP. So I'm not doing on CloudGuard 2 because we're gonna use those floating IP. Okay, dynamic group. Okay, so as you noticed, like in the beginning, when we were creating a Terraform stack, we were focused on, like I was showing, we were creating a dynamic group and policy, which is responsible for doing an HA failover. So this is the dynamic group which we created, demo 2. So if you see here, in this dynamic group, we have two instances here. So you can see the role builder here. You can select the instance of it and paste it here. These instances are nothing but the Terraform, CloudGuard instances. So if I click here, go to instance, confirm let's click on CloudGuard 1 here, is ending with a JQ, right? So you would see there's a JQ here, 4JQ. There's the CloudGuard 1, and this is the CloudGuard 2. So the intention is we create a dynamic group, you assign that instance, so the dynamic group, only those instances has those access to the dynamic group, and there will be a policy attached to the dynamic group. So this is the dynamic group, which, as you know, we created on root compartment level, and then we assign a policy, right? So in this case, you can assign a policy on compartment level, or if you define a policy on the root compartment level, then you need to have a path pointing to that compartment. So this is the policies. So currently I'm allowed like a dynamic group to manage all resources. You don't have to create all resources. You can follow the official guide of Checkpoint. In a nutshell, what they need to have access is like instance VNIC and the VCN part, like a virtual networking part. So if you see, I'm putting a dynamic group, dynamic name, manage resources in compartment. So this is defined at a compartment level. But if you're doing at another compartment level, then you need to have a path to your networking and compute resources. All right. So there's the dynamic group, which we covered instance OSID here. Policy, which we covered the policies here. What is the policy looks like, which I showed you how the policy looks like. And we finished the policy. Okay. At this point, we should see like all those instances are created successfully. Since we already have using the Terraform, we already have instances running, so that's fine. But just for visibility point of view, I just wanted to show on the workshop we are saying that make sure that instances are there. We already have the VCN ingress route table entry. We already have the backend trust interface IP. So how you can get those IP, which I showed you in the beginning, you can go to instance here, click on attach VNIC, click on backend, and this backend has a IP address like 2.4. So if I go into my VCN here, you would see my firewall VCN. Okay. So VCN ingress route table, it has 2.4, right? That's the one which we are using. So that's the same IP which you see on the backend interface type. So that's what I'm saying it here. Make sure that VCN ingress route table has a backend secondary IP, private IP address. Okay, the backend route table, we already covered the DRG part, which I showed like how you can attach the DRG, and it will know based on the attachment, it will understand the DRG attachment, and you can route the traffic back to the DRG. Same way, default route table, it doesn't need to have those entry, but I just added for test purpose only. Service gateway. Okay, service gateway, it should have its own route table also, right? For example, this is a service gateway. You would see there's a route table here. This route table is responsible to send a return response to the firewall. And in this case, if you see the service gateway route table, it has a like a return response. I'm saying 00, but in your case, it changes. I'm sending it back to the backend interface of floating IP. Okay. This is the backend interface IP. Okay. And the last step is like doing a sanity check to make sure that the firewall VCN or the spoke VCN, they have different subnet or construct like VCN ingress, attachment or service gateway. So make sure that you have the correct route table entries are there. And you can always modify the route table, which I showed in the beginning. So if you can firewall VCN and go into particular subnet or logical construct like a service gateway. Let me just show it here. You can attach the route table, associate different route table. All right. So at this point, this route table, everything is covered. So at this point, lab 2 of this workshop is complete, which I showed. You were able to see like what are the different CloudGuard firewall as well as CloudGuard management platform. We were able to cover like the additional interfaces, assigning the secondary IP, dynamic group, policies, and then updating the route table. Okay. Now let's move to the fun part, which is deploying the CloudGuard firewall on your, initial configuration on Checkpoint CloudGuard Security Gateway. So in this lab, what we're gonna cover the initial configuration on management platform as well as Checkpoint CloudGuard firewall, primary as well as secondary. And when we're gonna use the smart console like as a application provided by Checkpoint, which allows you to connect to the management platform And from there, you can manage the firewall configuration of like policy posts or routing and all. You can do that from there. So the first step of this task is you need to have update the admin password. So what we're going to do, we're going to grab that instance public IP of management platform. Okay, let me know if you can see my screen, Jeff.
I can see your, yep, I can see
Terminal, right?
your terminal, yep. If you want to, yeah, that's, can you zoom in at all? Are you able to do that in this terminal?
I can. Is it better?
Yeah, it's getting better, a little more. That works. Thank you.
Okay. So I already have my private key as part of my terminal. So I didn't pass that key, but if you have your own key, you can just pass it from your terminal or whichever, however you're trying to access it. All right. So the first step is making sure you set up an admin password. So we're going to set up an admin password here. I'm going to choose the same value which sorry, let me just cancel it. I'm going to choose the same value which I passed in the workshop, but you should choose your own unique password. Okay. So at this point, the initial configuration of management, how to access from the GUI is there. So I'm going to point it here. So enter your admin user and the password, which I just entered, which I just set it on the CLI level. So this, what we're going to do, we're going to do the initial configuration on management platform first. So which allows us to make sure this instance up to date, the configuration which we want to push. So you can follow the workshop also, but I'm going to just show it quickly on each step. So click on next part. Continue with the R81 release configuration. This will be the default management IP. So let's keep it as same. Update the host name. So checkpoint manager. If you have your own DNS server, you can add those values. Make sure the time, since already specific time, I'm going to keep that default value. But if you have different time zone, you can set it up.
Yeah, in general, making sure your time is accurate is just like anything else. It's pretty critical, especially for cluster operations and API operations.
Mm-hmm. Click on next, then security gateway and or security management platform. So in the next step, you will see we're gonna just focus on security management because this instance will act as a management platform. So
yeah, so this is the critical part here in this part of the lab, making sure to uncheck security gateway. If you leave security gateway checked, it'll actually employ some of the firewall components and then can cause some headaches as far as communication between management and the firewalls. I'm sure if you're familiar with the checkpoint, you are aware of that, but just in case you aren't, make sure to uncheck security gateway.
Okay, that's good. Okay, then click on next. I'm going to keep the default admin for GUI access. So if you want to create a new one, you can create a new user if you choose to. I'm going to allow any IP, but if you want to restrict access from GUI, you can choose it depending on your own machine or some certain subnet or range. Okay. You want me to select this? Okay, I'll keep it. All right. So at this point, the initial configuration is complete. So what we're going to do this finish. So once it happens, it will ask us to confirm it, the initial configuration process. So which will happen in the background. So which takes like a couple of minutes time. So what we can do, we can move to the next step. So the next step is like, as you see from here, which we did initial configuration, next IP address, which is host name, NTP, installation type, and checking that box, which we covered, admin user, IP addresses and all, and finish, is going to happen in the background. So we can focus on the next task at the moment. So next step also requires updating the password, updating the admin user password. So let's connect to the CloudGuard one first. So I'm just copying this value here, but I got to type it, but the intention just to show you like the instruction is up to date. All right. So let's do that. Enter your username and the password. I'm keeping the same password for test purpose only, but you should enter your unique password. All right. So when this happens, so there you'll see a certain window. So in this window, there are a couple of options here, which you need to make sure that you have the right value. So first we'll like the host name, CloudGuard, which you want to modify. Keep those management IP as same as it is, like the front end IP. Enter the admin password, which we just entered. So you can choose the existing password. Or if you want to enter a new password for admin user, you can do that. This key will be used for making sure the management platform can connect to that CloudGuard firewall. So this will be used when we create a cluster through the smart console and all. So you will see in a bit once we go there. But behind the scene is the activation key and all should be there.
Yeah, and just another point on an activation key, in case you said, I apologize if you already said this, but the activation key is not, and this is just for people that aren't familiar with Checkpoint completely. The activation key is not a license key. It is simply just a one-time password, essentially, that we will use to connect management to the firewalls. And this can be whatever you want it to be. I think there is a character limit in certain instances, but in this case, I think it's pretty basic. But yeah, it's just a one-time password that you will use to connect your management to the firewall.
Exactly. So I'm going to keep the same key for the passwords because I know I will remember that. So, and make sure this you enable the cluster membership because this CloudGuard will be part of a cluster, another with the CloudGuard too. So you select that box. Okay. So at this point, once you click on go, it should says requires a reboot, which is pretty normal. So it's going to happen in the background. So let's move to the next task at the moment because this will take some time. So what we did, like connected the admin user, we updated the host name, admin password, SIG key, enable this box, and confirm those value and reboot it. So once it reboot happens, you will see this console in a bit. So I'm going to skip that part for the moment. We'll come back to that again. So let's connect to the CloudGuard 2 instance now. Do the same thing on CloudGuard 2. So this time, let me pass that SS key, which I have. Right. enter the host name, CloudGuard2, enter the admin password, enter the SIG key, which Jeff talked about. Okay, so at this moment, finish successfully. Okay, interesting. This time it didn't ask me the wizard, right? All right, so at this moment, like it takes some time. So what I'm gonna do, like I'm gonna move to the next part of the same task 4. So in this task 4, I need to have like access to the smart console. So this is like a Windows application. So as long you have either using your own Windows VM or a certain like virtual machine, yeah, so you would need to install this application on your Windows VM. So currently I don't have Windows VM, so I'm gonna create a Windows VM for me. So it takes some time for rebooting, and also I don't know, like if you want to wait or if you want to take a break and circle back, Jeff.
Yep, sorry, multitasking here a little bit. Yeah, we can take a quick break. Let's see if I forget what type of break. I think we do like 10 minutes on this break.
Okay.
So let's do a 10-minute break. Just to make it easy, we'll start at the top of the hour. So technically like a 13-minute break. So we will start again at the top of the hour. Once again, if you have any questions, feel free to ask in the chat, or actually in Q&A preferably. Happy to answer any questions you may have. Thanks for your patience. Thanks for sticking on with us and watching. Really do appreciate it.
Sounds good. So meanwhile, I'm just gonna connect to that Windows VM. All right, Jeff, I think we can start.
Yep, we can. Thanks, Ryan.
Okay. All right.
One thing, yeah, real quick before we get too far. Just a quick thing to point out is, we're deploying a management server as part of this lab. Obviously, if you have an existing management server, that can definitely manage all of your OCI environment, which is, for those of you that know Checkpoint, that's probably very obvious. Also, in regards to the smart console that we're installing right now, that can live on pretty much any Windows device, any Windows system that can access the management server. So just to point those two things out as we continue here.
Yep, sounds good. So as Jeff mentioned, I was installing the smart console in the background because I had to create a Windows VM and all. So what I just did, I just copied this one and trying to install it. So this is currently installing it. So before we move to the task 4, let's go back to the task 1 again. So our manager should be fine now. Okay. So the task 1 is complete of the workshop, which is like the management initial configuration. It will take you to this page, but we're not gonna manage it from here. We're gonna use the smart console. Then the second task was the task 2, which is the CloudGuard 1. So we did the initial configuration. I think boot should be successfully completed. Okay, it's fine. So the next step onto this task is like creating a static route. So you'll see a comment here. So once the host reboots, you'll be setting a static route. So this static route is responsible to send the return traffic towards backend subnet gateway for the spoke VCN. So if you see here, so the intention is like the spoke VCN or any other VCN like where it wants to do, you need to have a route on each firewall. So the idea will be like in this CloudGuard 1 and CloudGuard 2, you'll be creating a static route, which is like, okay, if you want to talk to spoke VCN, go via backend subnet gateway. And the gateway is like a first IP of the subnet on OCI. So in this case, like if I connect it here, so if you see from this workshop, what we're doing, connect to the console, and I'll show you like how you can create a static route, but behind the scene, the backend subnet gateway is 2.1. So let me just double check what the VCN looks like. This one, okay, backend subnet is 2.0/24, the 2.1 will be the gateway. So what you do here, you can, if there's a configuration log, you can enable it by clicking here. Then you just click on IPv4 static route, click on add here, enter the destination. So I'm gonna do, I could do like a web and spoke PC insider also, but only for test purpose, I'm allowing /16, but in production environment, you should enable only what you want to enable. Okay. So the intention would be like, since we have two VCNs added, which are sitting in /16, like 10.0.0/24 and 10.0.1.0/24, which they will fall into this range. So what they will do, like they will follow the backend subnet gateway to go out. This in similar fashion, like if you follow the workshop here, what we did, the static route entry, make sure that gateway, everything is there. And the task 3 is the same way. You're gonna, once the host reboots, you're gonna have the static route. So this is our CloudGuard 2. In the same manner, you add the static route entry here. Okay, click OK. All right, so both of the route entries are there on the, we did the initial configuration on CloudGuard 1, CloudGuard 2. So now the next step would be managing the cluster from from Smart Console. Okay. So CloudGuard 2 is there, static route we just added, everything's fine. Okay. So if you see from what I was doing in the background, I was trying to install the Smart Console using the same link which is provided on this workshop. So I was able to install it locally. So we can finish. So this Smart Console, what we're gonna do, we're gonna connect the management platform from the Smart Console. And from that management platform, you're gonna add the cluster and we're gonna manage the initial configuration of the adding the cluster, and then we'll move towards the traffic validation part. Okay. So enter your username, password for which we did for management platform. Copy the IP of this one here. So once it comes up fine, you will see like we are able to connect to the management platform from the Smart Console. And then we're gonna follow along the adding a cluster. So this is just a Smart Console we have just added here, accepted it, and you will see that we're gonna add a cluster here in the next step. Give it like okay. Now this is the same manager, which is a checkpoint manager. This understand the host name and all, which we just created in the beginning. So it knows the private IP of that associated to the public IP. Okay. So what we're gonna do, we're gonna add a cluster here. So let me see if I can zoom in. Can I zoom in? Oh no. This takes me to. So click on cluster, add a cluster here. Enter the cluster name. So, okay. Actually, while zooming in something, block, whatever. Okay. So the first step we just did the click on wizard mode, enter the user-friendly name. So we're gonna enter the cluster IPv4 address. So this IPv4 address will be the secondary public IP address associated to primary, which is a front-end interface of CloudGuard 1 instance. So what's going to happen? You're going to go to CloudGuard 1, find out the attached VNIC, go to the primary VNIC, which is the front-end interface, grab the secondary public IP, which is what we're trying to do. And correct me if Jeff, I'm wrong. This could be a private IP also, right?
Correct. So, right, we can entirely encase the cluster without having any internet access. So we would, in that case, we'd use the service gateway as our access to the Oracle API.
Exact.
So correct. We're not. Yeah, you're not required to have your firewalls exposed to the internet.
Exactly. So we are doing this cluster in high availability. That's the reason we selected the checkbox when we're doing the initial configuration on CloudGuard. So click on next. Oh, sorry. At this point, we're going to add the cluster member. So let's do CloudGuard 1 and let's follow the instruction. Oh, sorry. So we add cluster member. So the name which we just entered, the IP. Okay. Enter primary interface private IP address of CloudGuard 1 instance. So what we're going to do, we're going to go to the instance here, attach VNIC. So CloudGuard 1 primary VNIC is like this is the primary first IP. But if you are just curious, you can go into the front end interface here and find out that primary unique IP. So this is the same IP. So which we need to enter here. So this will be IP address. And this is the secure internal communication key, which we enter in the beginning. So this is the unique key which you need to enter. So once you enter that here, you can have an initialization from here. So that will tell us, okay, there's a trust is established or not, right? If there's an error, then you need to update the SIG key from the CLI on each firewall. Okay. Or, okay. Okay, so at this point, CloudGuard 1 is there. Let me add a CloudGuard 2 also. In the same manner, I'm going to grab the IP of CloudGuard 2. This will be the primary IP. Click in slides. Click OK. Okay, so at this point, both of the cluster members are there. So if you follow the workshop outline here, we added this CloudGuard 2 also, CloudGuard 1, which we just did. Same manner, we added the CloudGuard 2. Trust was established, and we do it sanity check just to see all those variables are right. So click on next, and then we're going to finish the cluster creation here. Then we're going to move along that importing the topology and updating the interfaces and all, adding the floating IP and all in a bit. So once you do that, you should see this cluster is created here. Have a double click on it. Okay, click on network management. Click on get interfaces with topology. So what we're trying to do, we're trying to connect to each CloudGuard member based on that SIG key and all. So it's gonna grab those private and front end and back end IP. So you see this CloudGuard 1 and CloudGuard 2, they are the front end and back end IP. And we're going to assign the virtual IP. This virtual IP will be the floating IP. So click on each 0. So if you follow it here, we just selected it, double clicked on it in the each 0, which we just did after importing the topology, right? And get interface with topology. So this is the IPv4. So this virtual IPv4 address of the each 0 interface, which is like enter secondary private IP address of primary interface on CloudGuard 1 instance. So go into CloudGuard 1 instance, because CloudGuard 2 doesn't even have the floating IP at the moment. So this is the secondary private IP, which is a floating IP, which we need to enter on each 0. So select the cluster network type as a cluster only for each 0 and test, because each one will act as a configuration sync and HA sync part. Click on OK. Same way do that each one, which is cluster plus sync. So it will be the alert. Click on OK. Yes. So we added each 0, each one floating IP, and we just added that we selected the OK value. At the moment, there's a default security policy, which is a cleanup rule. So for test purpose only, I'm going to update the cleanup rule and have allow all. But in production environment, you should select only you should add only required policies. Select action here, accept. enable the tracking logging. Okay. So at this point, policy is there. We added the cluster. We imported the interfaces on the cluster. We assigned the floating IP and all. So what we're gonna do? We're gonna publish our changes first. So publishing is like staging those changes before you commit to the firewalls.
Right. For those of you not familiar with the checkpoint, again, a publish is, essentially what you're doing is you're submitting the changes to the management server database, and then which doesn't actually push any policy to the firewalls themselves. The next step where we install policy will actually push those changes to the firewalls.
Exactly. So let me do publish here. And let me go back to this. Okay, so we just did publish, and so you could have done publish and install also, but I'm just showing you publish first and just to understand it. All right. So publish changes are there. Now let me click on install policy. And it will take you to this where it's trying to install the policy, that whole cluster, and you'll see the target also if you want to see. Click on install. So in a bit, like you would see this in task manager, the successfully gets applied, and then this cluster member, they will turn from like red to green in a bit because it takes some time to synchronize. So what we just did with the policy, we just posted. So in a bit, you will see this green check mark on all those cluster and as well as cluster member. All right, so this was successfully applied, and this red one, they should turn green in a bit. So we're gonna move to the next lab environment. So which is like, if you click on next part here. So this is like traffic validation. So there are certain traffic which we're gonna validate. So let me go to the architecture looks like. So what we're gonna do, we're gonna connect from internet, and then we're gonna use the backend front-end interface public IP to connect from outside. We're gonna define a net rule in a way that we're gonna connect to a certain port. So in that way, we can connect to this web spoke and database. It's not required, but for the workshop purpose only, I want to show like north to south inbound traffic. So this will be like internet to firewall, exiting from the backend subnet gateway, going to the DRZ, goes to the web VM, return response, follow the same path DRZ towards the firewall, and the firewall understand based on the netting and all, it knows which flow it send it back to and goes to the internet again. So the same way, like we're gonna do the north to south inbound, then we're gonna do north to south outbound also, like web VM trying to reach internet, goes to the DRZ, goes to the backend subnet based on the vCIN ingress route table which we have, goes to the CloudGuard firewall, traffic inspection happens, exited from the front end side, goes to the internet. And same goes for east to west traffic, web VM to database or database to web. So web VM will come to the DRZ based on the attachment, goes to the vCIN ingress, comes to the firewall, firewall inspect it. Firewall has a static route towards spoke VM. So it's going to follow the backend subnet gateway, comes back to the DRZ. Based on the import route distribution, it goes to the spoke VCM of the like database, or if you have another spoke VCN and all. In the same manner, I'm not going to cover like object storage, but the idea will remain same. If you're trying to access to object storage, object like bucket or object URL from the spoke VM, follow the same path DRZ to the backend subnet towards the firewall. Firewall will have a route which says if you want to reach to this object storage network, follow the object subnet gateway and backend subnet gateway. And backend subnet has a route which, as you noticed earlier, we are pointing to the service gateway, right? Then in the end, we're gonna cover a failover. We're gonna do a like I say failover from this one, and we're gonna see this floating IP moves from both of these interfaces to the secondary firewall, as well as the traffic resumes. All right, so for test purpose, the first one, inbound traffic. So there are certain network objects which we're gonna create. As I said, like we're gonna use the front end public IP, but public IP get translated to private IP. So we're gonna attach, create a object, network host object on as well as the web VM object at the database. So let's start from the web VM first. So go to Smart Console, search for the new. Okay, let me just double check. Okay, everything is green here, which is fine. Click on host here. You can also add those hosts from CLI, like you can click on command line here, or through an API or some sort of automation. How do you want to do it? So let's choose this web VM 0.66. Okay. I can create a new one, or I can clone the existing one. So let me just select web app VM. You're gonna cancel, clone. So the next one is the front end private IP. So let's click it here. And this will be the instance. Let me go to the attach Phoenix of the CloudGuard 1. We're going to use this IP of the front end. Let me show you quickly. So what we're going to do, we're going to use this public IP to connect from outside. So remember earlier I was saying, like, if you can assign additional IP. So if you don't want to use this interface with this interface IP, you can assign another IP, and our private IP will be that IP. But in our case, we're going to use this public IP to connect from outside. So I need to create an object using this IP. In similar manner, we're going to create a database also. So DBVM, this is the DBVM. (127), okay. All right. So we have those objects. So now the next part is, as I mentioned earlier, I'm gonna connect from outside. So I need to have different like a TCP port. So in that way, I can connect to web VM or database VM. So I'm gonna assign two different unique ports. So what we just did, we created those object, web app VM. Then we did the front end private IP also. Then we did the database one. So we're gonna create two different TCP service. One is for web and one is for database. So all right. So both of those 177 and 1778 port is there. But how would you connect from outside, right? So you need to have those net rule which I talk about. So database is there. Okay. So we're gonna create a zone on the. We're gonna define that zone on each zero interface, and we're gonna use that zone to connect from outside. So in that way, any traffic hitting that zone get translated to that front end private IP. You will see in a bit like how the zone policy looks like. So to create a zone, the first step is we're going to assign a zone to the interface level. So go into cluster again. Click on network management here. Specify security zone. You're going to choose an existing object, which is external zone. And okay. Okay. So after creating the zone, we already enable the log. So, but this is the policy or the net policy which I talk about. So if you see from here, the first one is just to make sure that on the manager level there is no net rule is no policy is hitting the manager level point of view. So that's why we're creating an object for security manager. And the bottom two is what we're going to focus for north to south inbound traffic. So the first one, as you see here, is going to be based on the zone level. So it's going to hit it from outside. Once it hit from outside, it's going to know the destination will be the private IP, which we're trying to connect from outside. We're going to use a certain service like a 177 port. And this is going to do a translation to the web VM and the unique port which where you want to go, like SSH port. In the same way, database, like hitting from zone side, from outside, it will know about the front end private IP. We're going to use the 1778 port, and it's going to go to the database VM. So we're going to create these three different net policy to make sure that before we proceed and do the traffic validation for task one. So click on policy here, click on net, add rule to the top. Choose the manager. I think everything is any okay. I think it's same. Can choose, add another rule here, add rule below. Choose this one. Choose your zone here. So we're going to use 177 from service from outside for the web VM. And source will be same, and destination would be the web VM. And service will be, we want to go SSH on the web VM. You can clone this one also. So you can copy. All right. So at this point, we have this is allow all policy for security point of view, and this is the net policy. The first one is for just to make sure on the management platform, management instance doesn't follow into the net policies. The bottom two one is that we're going to focus on and connect from outside. So as earlier, like what we did, like publish and changes. So we're going to just publish our changes. And then install the policy. So what it installed in the background, this is just a quick summary which added, you can do a sanity check before you proceed, make sure there's object and everything is there. So that once you do the install policies and all, we should be able to connect from outside. So let me go back to the instance, which we already have here. So this is the front end one. So I'm going to use this public IP. And let me go to my terminal. So OPC is just a username for the Linux VM. 1777. Okay, so the top one should take me to that web VM, and the bottom one should take me to the database VM. Okay, so if you see this IP address is the 0.66, and this is it should be in the 1.27. All right. So this tells us like we are able to connect from north to south inbound. So using the public IP and a certain port, and you are able to connect from inbound traffic, right? So if you're curious just to see like our task was successfully completed, and if you want to see the log, like you can click on the log here. So let me bring it up. Okay, you would see this is the log here. So I'm using from my public IP and I can connect to this VM and it hit that net rule, which is the web VM 0.66 and is going through the CloudGuard one because that's acting as a primary firewall at the moment. All right, so that was the task one, which we want to cover, like north to south inbound traffic. So we were able to connect from outside. So now let's move to the next part, outbound traffic. So if you see from here is this VM, if I try to do ping google.com or any outbound, I'm not able to ping because currently on firewall level, you need to have like netting, hide net in a way that when the traffic goes out, it uses the untrust interface to go out, right? So go into this smart console one more time, search for app VM. So let me search for the object. So click on a web app object, click on net here. Okay. So once you do that, so in a nutshell, like let me do here 1 second first. You would see there is no net rule into hide net rule, right? So what's going to happen? So as soon as you enable that, it will dynamically create a net rule, hide net rule for your object to go outside. This one. Same way, database VM. All right. So those net roots are there now. So I can do, I can go and publish my changes and install it. All right. So what we did, like we just enabled the hide net rule. We did the sanity check just to see the net rules are there. We did the publish and install policies and all. Which since we already connected to the VM, so what I'm going to do, hopefully this ping which was running was stopped, will resume in our case. Okay, it's not running now. Let me do ping google.com. Okay, so as you see, it also proves that north to south outbound traffic is also flowing as expected based on the firewall is inspecting and all. So if you are just curious how to track them, so you can do service SCMP. Okay, so these two one. So database VM is trying to do ping to destination like a Google one, and same goes for web VM. So if you click here, it will tell you like it is it's going to the CloudGuard one. It's trying to going to the each one interface, which is the backend one, and then it goes to the outside from the each zero, right? All right, so that was the outbound traffic which we covered. Like we were able to validate the google.com or any outbound connectivity, and we were able to see the traffic log here also. Okay, next part is what we want to do. We want to send the traffic from web VM to database VM. So since we already have policies and rules, so ideally it should work just like that, but let's just double check. So this is the database VM. So if we follow the flow log, which we have been covering here, the database VM will go to the DRG via attachment, go to the backend subnet, go to the VCN and through the VCN ingress route table, go to the backend interface of the firewall inspect it. Based on the route, it will send it to the backend subnet gateway. Backend subnet has the route pointing to DRG again and goes to the another spoke VM. So if I do ping from here, you should see the ping from database to web spoke is fine. And if I do ping here from web to database, it's also working as expected. You can do the sanity check from firewall also, like smart console. Go into policy, search the same one. Let me just refresh it here. You will see web to database is also going and database to web is also going. I'm going to the CloudGuard one. In the same manner, this is the task for watch. I'm not going to cover it, but the intention is still the same. Like you create an object bucket, upload an object here. Once you do that, then define a route table, route entry on both of the firewall to make sure for your object storage network. So in this case, it's an Ashburn. Goes through the backend subnet gateway instead of a default gateway, which is the front end subnet gateway. And since we already have the route entry for service gateway and all, so it will follow the same path. All right. So the next part which I want to cover is the high availability. Like how does the floating IP, does it move? Like how does it look like from the point of when the HA failover happens, and how does the traffic resumes and all? So what we're gonna do, we're gonna connect to, it's only for this R81 release. So we need to run this, go into expert mode. We need to run this this bundle command as well as the CDI command just to restart for the HA failover. And I believe, Jeff, correct me if I'm wrong, this will be resolved in the next release and so, right?
Yes, and we're in the process as we speak of testing out the fixed images that will have this included, so we'll not have to do this manual step.
Exactly. So what I'm going to do, I'm going to connect to each CloudGuard instance. So let me open a new tab here. Enter your expert password, a unique password which you want to enter. Go to expert mode. Go to the same, do the same thing on a CloudGuard 2. Enter your unique password, which you want to set it up for expert mode. All right. So at this point, we have the prerequisite to have the HA configuration running. So if you want to see the cluster state, you can show cluster state here, which will tell you the CloudGuard 1 is acting as active and CloudGuard 2 is acting as standby. Same way, like it will tell you, sorry. Same way it will tell me on the CloudGuard 2, which is active and standby. Okay. So what's going to happen? We're going to bring one of the cluster member down. So once we do that, we should see two aspects. One is like on the CLI level, this should change like which one is down, which CloudGuard 2 should become an active member, as well as behind the scene, the floating IP should move and the traffic, there might be some small interruption, but the traffic should resume. So in this case, like we have an ongoing traffic from web to database, as well as ongoing traffic from database to web. So let's bring down one of the primary firewall cluster. You can also reboot the instance, but I'm going to do it from CLI. Okay. So, okay. So once I brought it down, you should see the CloudGuard 1 became down. CloudGuard 2 became inactive, which was expected. And there might be some drop here. As you see, like currently traffic is not there at the moment, because it takes some couple of seconds before the floating IP moves from primary instance to the secondary firewall. So we're going to CloudGuard 2 here. Let me open CloudGuard 1 also. So IP, the floating IP, any IP beside the primary IP, all of them, they will move. Okay, so you see the floating IP moved from the CloudGuard 1. And if I go into CloudGuard 2 here, which is our primary firewall at the moment, Okay, floating IP moved here. If I go back to this, traffic was resumed also. So you see there's a ongoing traffic. And if you are curious just to see where it is being going, is it taking to the CloudGuard 2 or not? You can go into same log level here. You see CloudGuard 2 is acting as a primary firewall at the moment. So it tells us, okay, HA failover worked as expected. Floating IP of backend and the front-end interface also moved because of our dynamic group and policy, which are needed to support that effort. So what we just did, like if you see from the workshop, I was creating a reboot, but I could also reboot if you choose to, but I was just showing from the CLI level. We were able to verify the floating IP moved and all on both of the instances, as well as traffic resumes. So that pretty much covers our traffic validation part. In the next lab environment, like we are trying to destroy the environment, but that's not the use case for this workshop. So I'm not going to focus on that. But if you, since it's the Terraform provisioning, you can do the Terraform destroy if you choose to. All right. So I think that, yeah, thanks, Jeff. So I think that's pretty much, we covered the workshop outline and we showed you how you can deploy the checkpoint, a CloudGuard solution on OCI console, as well as how you can use that to secure your workloads based on security policy and net policy. Hopefully it was helpful.
It was. Thanks, Arun. If anybody has any questions, we're here for, we can wait out for another few minutes. Otherwise we will let you carry on with your day. We really appreciate your attendance and your patience and your soaking in all the information. I know it was a lot. As we said, we will be posting this, or we will be sharing the full presentation, or the full video, I guess, with you guys in a few days. And as we said before, that workshop link is available all the time, so you can kind of walk through that whenever you need to. And also in regards to the Terraform stuff, as if you know about Terraform, you can take those Terraform templates and customize them to your heart's content, you know, to the needs of your environment. So there's a lot of good information there, a lot of good resources to make use of going forward. So thanks, Arun.
Thanks, Jeff and Christian. Thanks a lot.
Yep. We'll probably wait like 1 or 2 minutes and then we'll drop off. Everyone have a good rest of your day and a good weekend.
Yep. Everyone has rest of the day and as well as the weekend.
Thanks, guys. Congratulations. Appreciate it.
Thanks, Jonathan, for staying on with us late. I know you're on the eve of your weekend.
Exactly. I'm on my way.
Right.
Thank you, everybody.
Yeah, thanks everyone also.
Thanks, everyone.
Thanks, Christian.
Yeah.
All right, I think we can drop. Take care, everyone.